Welcome, everybody. We'll get started in just a moment as people are settling into their Zoom seats. Thank you for joining us and start in just a moment here. I am wearing a heavy sweater because it's cold here in the Northeast and would like to tell you our guest, Dr. Madan, is calling from Houston where they've had a snowstorm. So should we have any glitches or internet troubles, just know we're working against that with our technology today. All right. Hello, everybody. Welcome. Thank you for joining us. I'm Dr. Jeff Katzman. For those of you who have not joined before, I'm the Director of Education here at Silver Hill Hospital. And as always, we are just delighted to have you join us and are privileged to welcome Dr. Alok Madan, presenting on the topic, the brain-gut interface, how the gut microbiome affects and is affected by psychiatric illness. I'll have the pleasure of introducing him in a moment, but we'll let you all know this topic is of great interest. We had our greatest number of registrants for any course to date. So thank you so much, Dr. Madan, for joining us on what will promise to be really an inspiring conversation. A bit of housekeeping, as always. Our next Grand Rounds takes place on Wednesday, February 12th with Dr. Joseph Goldberg, who will talk to us on the topic of understanding pharmacologic management of treatment refractory mood disorders. So please join us again on February 12th. Also, if you visit the Silver Hill Hospital website calendar under Education and Resources, you will find some upcoming programs. We have one that we're calling TOP, TOP, which is the Treasure of Ordinary Psychotherapy. We have 5 different speakers who are going to be talking about common factors and how to bring yourself into the therapeutic relationship. So look for that and sign up to join us. And we also have one called the Mentalization Connection Series that is being sponsored by the Mentalization Initiative in Los Angeles that we're joining on as well. So take a look for those two. And back to today's lecture. Your questions remain an important part of our grand rounds, and I will moderate a Q&A discussion with Dr. Madan at the end of his lecture. It's really a great opportunity to put out any questions and comments to Dr. Madan, which you can submit anytime during the lecture by using the Q&A link. If you'd like CME or CEU credits today, please complete the evaluation survey that will automatically show in your browser when we end the webinar. We'll also email a copy of the survey to today's participants. Finally, in disclosures, no planners of this activity have indicated a relevant financial relationship with an ACCME to find commercial interest, and Dr. Madan will show a slide with his disclosures. It is now really a great pleasure and honor to introduce our guest speaker, Dr. Alok Madan, who I've had the pleasure of meeting virtually a few times and have been so interested in everything he's really ever had to say, and I was so delighted when he said, yes, of course, I will participate in your grand rounds. Dr. Madan is a clinical health psychologist with a 20-plus year history of developing clinical research and educational programs to improve the quality of care for individuals with chronic medical conditions and serious mental illness. At present, he serves as vice chair of the Department of Psychiatry and Behavioral Health and the John S. Dunn Foundation Distinguished Centennial Chair in Behavioral Health at Houston Methodist. In these roles, he helps lead a team of world-class clinicians and researchers to expand the continuum of mental health care services offered through Houston Methodist, as well as to build a research infrastructure from the ground up, all with an eye toward integrating novel technologies into service delivery. His personal research interests include examination of gut-based contributions to psychiatric illness and development of novel brain stimulation technologies. He holds full professorships at the Houston Methodist Academic Institute, Weill Cornell Medical College, Baylor College of Medicine, Texas A&M University, and University of Texas Health Science Center at Houston. He earned his doctorate in clinical psychology and Master of Public Health degree from the University of Alabama at Birmingham. And with that, again, Dr. Madan, despite sleet and snow and a city that's unprepared to deal with it at all, with not even a snow plow, thank you for joining us, and um, prayers to the internet connections that all stays intact. And thanks again, and I will pass the baton to you.
Appreciate that, Jeff. Thank you very much, and thank you all for joining today. It's this is a topic that's kind of near and dear to me. It's talking about kind of the brain gut interface. I've been doing this for 20 something years at this point, and kind of from the clinical trenches now to the kind of looking under the microscope. So this is a topic that I think is kind of part and parcel of kind of any part of the human condition, really, but really relevant to any mental health practitioner for the patients that we serve. I think this can inform and better take care of the population that kind of regardless of what their presenting psychiatric illness might be, kind of an appreciation of how the gut might be impacted, I think can help us clinically as well. So before we get started, let me talk about some disclosures. There's nothing really directly related to this presentation, but I do have funding from a variety of places that covers my salary. Whether that biases me or not, we'll leave it to you. I do have commercial ownership in a company that does personality testing. And then I'm a consultant with a Mindbloom Incorporated. They are a telehealth company that delivers ketamine at home for depression. And folks have funded me in the past. And just disclosure also on, we will be talking about some non-FDA approved approaches to manipulate the gut microbiome. So this is, take it for what it's worth. It is, FDA does not sanction what I'm saying. All right, so big picture, what are we gonna be doing today during our next hour or so together? I'm gonna talk about what kind of gut microbiome is and how this is implicated in psychiatric illness, and how we might manipulate the gut microbiome to improve our overall health and mental health well-being. But really, at the end of the day, this is the take-home message that I'd like for you to remember. So this is we talk about gut and bowel function and at home a lot. This is a few years ago now. My fully ripened teenage daughter, we were doing a free draw back when she was about 7 years old. She hates that I put up the slide, and I do it a couple times a year. So we're this is a magical flying unicorn pooping out useful stuff. And in this particular, bowel movement, we've got, I think, some lettuce. We've got a cabinet, a tablet, some strawberries, and maybe a cell phone. I guess the big point of this one is that, we do poop out a lot of useful stuff. That's you, me, everyone on this call, even, magical flying unicorns. There's a wealth of information in our bowel movements, and that's what we're going to be talking about today. It is that information there, and how to use that information. So, if anything, I'd like for you to remember that even magical flying unicorns do poop out useful information. This is a lot easier to have this conversation with a room full of people as opposed to me staring at the screen myself. So this is like, hopefully you're able to chuckle at that, and really part of this is to start destigmatizing our bowel movements. We're comfortable sneezing, we're comfortable coughing, but God forbid we talk about our bowel movements. And there's a lot of information in that poop of ours. So, all right. So what is the gut microbiome? All right. So these are all these little bugs, bacteria, viruses, fungi, and all their kind of stuff that they're consuming and the stuff they're producing that lives in our gut, small intestines and large intestines particularly. This is all of that stuff, all right? And the bacteria, it's in a kind of a normal person is, numbering in the trillions. Um, some 3,600 different species, and collectively weighs about 3 pounds. Curious, that's the same weight as the average brain. So it's our bacteria in our brain are, volumetrically similar. So now, why are we going to talk about the fecal samples? It's that every time we poop, we're getting rid of these bacteria, viruses, fungi, and all their stuff. It's it's available to us. This is information that is readily acceptable. This is not sticking a needle into a spine, and getting spinal fluid. This is not, getting puncturing our brain to get, down into anything. This is just, we have bowel movements. You, me, everybody, every mammal. Where we have bowel movements that are readily accessible with information. Now, a few things to keep in mind while we're talking about the gut microbiome as being the bacteria, viruses, protozoa, fungi, and all this. The vast majority of research has really focused on the bacteria, less so on the viruses, less so on the fungi, and all this. So this is really, in some regards, the gut, bacteriome that we're going to be talking about. And there are a lot of factors that affect our gut bacteria. This is the food that we eat, the medicines that we take, kind of where we live on the planet, and how old we are, and kind of lifestyle stuff, how we physically move, the stress that we experience, and including just kind of how we came into the world. So, you, me, all of us, we were actually born with no bacteria. And as we pass through the birth canal, or if we came via C-section, we touch skin. So the birth canal is our first exposure, but as soon as we touch mama, our fathers, our aunts, uncles, grandparents, as soon as we start touching the world, we start accumulating this bacteria, and kind of, the first foods that we consume in life, whether that's breast milk or formula or whatever, it contributes to the development of our bacteria. So we're all born kind of what's termed germ-free, and then we develop this bacteria through life. Now, what is this gut-brain microbiome access? It's a symbiotic relationship. So everything that's happening up here affects our gut, all right? And it's back and forth. And this is throughout a lifespan. And you know this as well as I do, just intuitively. And we've known this for years, thousands of years, millennia. We have terms like butterflies in our stomach, scared shitless, right? That's the English language. This is these terms are found across the globe, and really, it's kind of the big picture is kind of there's a back and forth communication between our emotional, cognitive, and behavioral space and kind of what's going on in the gut. You may have experienced this. I've experienced it. You get nervous. Some people get gassy. Some people get bloated. Some people have diarrhea. Some people get constipated. Some people have stomach pains. And this is a very complicated back and forth that is really has to do with the bacteria, but then it has to do with big kind of CNS kind of structures and function, including the HPA. You've got neurotransmitters thrown in the mix, and kind of what the bacteria are actually producing, and how our immune system interacts. So this is a complex inner story that I'm going to get a little bit into the muck with, but not too much. This is like, don't want to get into the microbiology specifically, but we have to kind of talk about it to some extent. All right, this is a very, very, very busy slide. And in some regards, for its busyness, it's also quite simplified. So towards the bottom is kind of a reflection of what our intestines are, right? And this is what's going on in our gut, right? These are all the bacteria and kind of all the things that they consume, the things that they feed off of, as well as the stuff that they produce. So you're going to get some of these terms. So the bacteria um, are the bacteria, and then they're prebiotics, right? And then these are the things that they eat, and kind of their metabolites and their metabolome is what they produce. So this is all. So it's not just having what the bacteria, but it's the environment that the bacteria live in. It's the bacteria are consuming stuff, so we can feed the bacteria either good for them or stuff that's not so good for them. And then the bacteria can produce what they're supposed to produce. They can produce a lot of it, or they can produce a little bit of it. There are a lot of factors that go into this. And you'll notice a lot of these arrows are going one way, coming the other way. They're all bi-directional. So really to keep in mind that this is a complex story. At the end of the day, kind of how I've kind of synthesized my conceptualization of the gut-brain interface is, so think of all our bacteria and all of our kind of what the bacteria produce as being a volume switch on our or volume knob on our mental health and our emotional state. So, everyone's familiar with the diathesis stress model of psychiatric illness. So you have vulnerabilities that are often genetic or environmental, and then you break a threshold of exposure to environmental stressors that allow this phenotype of psychiatric illness to manifest itself. The way that I think of the gut microbiome is it can turn the volume up on that expression, or it can turn the volume down on that. And so you can have really big illness or maybe milder illness, and I think that is modulated via the gut microbiome. And really part of this is the story is emerging, kind of giving away the story, if you will, that it is the gut microbiome modulates our immune functioning and really our inflammatory response. So that's the big meta message is kind of this is complex bi-directional relationship of what's going on in the brain, the CNS, and the gut. They feed off of one another. They're influenced by one another. And at the end of the day, kind of what we do, what we consume, how we live, have bearing on that gut microbiome. And I think that gut microbiome has an ability to modulate the volume of the psychiatric illness that we may or may not be experiencing. How do we know this? All right. And I think this is really relevant to kind of taking home the big picture of how do we know what we know? What is our current state of affairs? What's the science underlying this? So, one approach is that we look at people without illness compared to people with illness and look at their fecal matter. Remember, this is 60% of our bacteria, our dead bacteria are there. So it's easy, it's accessible. And look at, differences in what those bacteria look like and what they're actually producing. So we can get fecal samples as well as blood to see what the bacteria look like differently in terms of number, quantity, density, ratios, all that good stuff, but also what they are producing, their metabolites, and what's actually floating around in our blood. So this is a relatively small number of studies out in the literature. And here's just for those of us that need to be aware, and all of us really, it's most of these studies are done in the United States, Western Europe, or China. So what we know today, I can't say is about the human condition. I can say that it is about, a part of the globe, but we cannot, geography affects so much of what's going on. This has almost nothing to do with folks in Africa. or folks in South America or folks in India. And that's, that's a big chunk of the global population. So I want to be cautious in over-interpreting this to say that this is kind of our state of affairs. This is the relatively small number of studies that are being done out there. And then the small number of studies are with a select number of people. And a lot of these folks are also women. So studies, 70, 80% women. So this is again, there are, gender differences too. So this is just something for you to keep in mind that we're very early in the state of the science, and the data that we have are limited geographically. So it's not overgeneralized to say this is part of the human condition. Now, another way that we go about doing this is kind of unique studies that are being done out there. We have folks with illness grab their fecal matter, and whatever the illness is, they're depressed, they're psychotic, they have bipolar disorder, they have Alzheimer's disease, they have Crohn's disease, they have heart disease, they have cancer. And we were doing this across all these. And then we get mice who we can create to be germ-free. That is, they have no bacteria. And we can transplant them with kind of sick fecal matter, a fecal matter transplant. And then we can measure and assess their behaviors. I mean, what we can do is we can get depressed folks, get fecal matter from depressed folks, transplant that into germ-free mice. And what these mice do is they evidence depressed-like behavior. We can evidence, anxious behaviors. Now, we're doing the same thing with humans. We can get folks who are healthy and get their fecal matter and transplant them into folks who are sick. And you can see that there is improvement. There's actually an FDA-approved indication for this, for a really bad kind of bacterial infection for C. diff, that if you get kind of C. diff that is not responding to antibiotic treatment, you've tried everything, you've done everything, and you continue to really struggle. The diarrhea is horrible. You're losing fluids, and you're ending up in the hospital about to die. Well, what the FDA has approved is a fecal transplant from healthy adults. Again, healthy is we don't even know what healthy is. So right now, where our big healthy fecal matter plants are really coming out of the Northeast, in the Boston area. And many of the donors are undergraduates and graduate students and medical students from our Boston institutions. So you're getting some BU poop to treat C. diff across the country. And then this is where I think where kind of the kind of the state of the sciences in terms of advancing our understanding today. It's manipulating the gut via dietary intervention. The whole field of nutritional psychiatry is up and coming. And we can change up diets, and that can have kind of direct bearing on our mental health. I'll get into some of the specifics after that. And then not just the diet, but what are these prebiotics or the bacteria? These are the foods that feed our bacteria. And then I suspect that anywhere from 10, 20, 30% of us on this call may even be kind of currently taking probiotics. These are supplements that are available over the counter that are bacteria in pill form, or really often gummy form, that are used to kind of supplement what bacteria we have in our gut and kind of hopefully change the balance. Now, here's just my public service announcement for y'all. It is know this much, that probiotics are a naturally occurring material, therefore are not required for FDA approval. So the stuff that is out there, as is the case with almost every supplement, you have to be careful that what you're actually consuming is what you think it is, and not just a gummy bear. Especially in our gummy forms, it's so just be kind of mindful of that. That hopefully that if you're supplementing with probiotics and that you're actually getting what they're saying, and there's some science behind that. We'll talk about that in a little bit. But it's also just a lot of it is nothing but just your gummy bear. So just fair warning. All right, so brain gut diseases, it's take your pick of kind of CNS disturbance, and there is a literature behind it. Whether we're looking at, MS or stroke or anxiety, depression, autism, or more neurodegenerative stuff like Alzheimer's or Parkinson's. There is a literature and science behind it. And let me summarize all of that for you. People with disease look different than people without disease in terms of their gut. And that is the big meta message. So this is kind of where the state of the science is. And this is the big picture too. People with disease differ from people without disease, and the way people with disease differ is there is less biodiversity of the bacteria. And so we don't know too much more than that at this point. We're beginning to learn more, but I can't say that we have identified this bacterial taxa, this bacterial strain, this combination, this ratio that are causal of any of these illnesses. So let's be cautious in interpreting the current data to what it's saying, that the gut microbiome is implicated across CNS disorders, and there are a variety of potential mechanisms, often involving kind of our immune functioning, as well as directly modulating CNS functioning in all of these diseases. So I've been involved with this field that I just created in terms of a label of psychiatric microbiology. These are two words that I just tossed into the literature a handful of years ago. Not that it's taken on a whole lot of traction, but it is I guess a new discipline that it's looking at our microbiology, our gut microbiome in the context of psychiatric illness. And this is by no means do I have ownership of this, but just to try to give it a label and a tent where all are welcome, because this is so complex. This is so complicated work. A health psychologist working with microbiologists, working with data science folks, working with, machine learning. We were really bringing together a motley crew of disparate languages, disparate conceptualizations, and really advancing a science that is so very brand new. Half of what we're doing is probably going to be debunked in days to come. But this is what happens when you're starting out. This is what we are. So about a decade ago, colleagues of mine and I, we started down the road of actually collecting fecal samples from adults receiving inpatient psychiatric care. January 1st of 2015, at that point, there were 2 published studies in the entirety of the empirical literature that actually looked at fecal samples from actual people with psychiatric illness. Two papers, one out of the Netherlands and one out of China. And that was it. This is kind of how novel this is. Now, it matters in that there's plenty of the literature. We're looking at mice, looking at animal models, or small healthy adults and controls, whatever. But mice are great. We can have mouse models, and they're a great starting point. But mice aren't humans, and not humans with depression, with anxiety. So it's the really our understanding and our conversation at that point, just a decade ago, was based on two published papers with real patients. So, to say that this is seminal work, I mean, we were kind of brand new in this, and a testament to the hospital at that time I was at the Menninger Clinic, for allowing us to collect fecal samples, and our patients were willing to give us fecal samples. And it's this is a closed, contained environment, which if you have fecal matter, well, there's plenty of good, useful information in it, and you can also have a bacterial outbreak and cause a whole lot of problems to a hospital. Fortunately, none of that ever happened, and I was in a fortunate setting to have a very, very unique population in that our patients were in-house for almost 50 days. We were collecting clinical data at admission, at discharge, and it was able to collect fecal samples shortly after their admission. So it is cross-sectional. This is, and that's there's a limitation to the study, but at this time, this was one of the strongest studies out there in terms of design, in that it was a contained hospital, where all the sheets were washed with the same detergent, the same pesticides were sprayed across the campus, the same cleaning materials. So all those environmental exposures, additionally, had information not only to medications that were prescribed, but what medications were actually administered and consumed, because it was tight. Nobody was smoking, nobody was drinking, nobody was doing drugs. So all of those factors that had the potential to really affect what the gut microbiome might look like were in many ways controlled for. In retrospect, we could have done a better job of really taking into consideration what people were eating. That was a design flaw, and one that we've learned from in subsequent studies we've kind of addressed. And at the same time, whether we didn't keep up with exactly what they were eating, it was a limited menu, and they had the same kind of dining service. So it's not exactly controlled for, but at least contained. And at that time, our 100+ adult patients who provided fecal samples, this was kind of among the largest studies ever done across the globe. Very, 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 very busy slide, so don't get caught up in the muck of this. I don't want you to. I intentionally keep this at a very small font so you can't see. So essentially, this is looking at people's bacterial makeup at admission and kind of their disease severity. So essentially, this is the red bars are mild depression, green bars are moderate depression, and the blue bars are severe depression. And down here, these two are anxiety. This is mild anxiety, and this is so essentially the picture was we identified a number of bacteria that were associated with kind of disease severity, and we kind of conceptualized depression and anxiety symptomatology as cross-cutting metrics of psychopathology, given that we had a heterogeneous mix of diagnoses, and moving away a little bit from kind of that categorical approach, and with kind of multi-comorbidity was the norm. So looking more at depressive symptoms and anxious symptoms. And the big picture, as I was saying, is various bacterial taxa are associated with disease severity. Curiously, what your bacteria looked like at admission, and the bacterial richness and diversity, was associated with how you did during the hospital course. So those patients who had kind of less bacterial diversity actually were less likely to respond to treatment during the course of their 50-day hospitalization. So we were able to identify kind of a early biomarker of treatment resistance, if you will, or treatment response or treatment remittance, however we want to conceptualize it. So kind of what your gut looked like when you enter the hospital in terms of its biodiversity was a predictor of whether or not you responded to treatment 50 days into the hospitalization, which is kind of awesome, right? So, I mean, we can have a picture of kind of what the bacteria look like early in the hospitalization and kind of associated with a disease severity when you're walking in, but then also to be able to say who's going to respond to treatment or not. Um, that I think is worth kind of advancing our understanding of science in terms of how we look at kind of if we had think about you and I, you know, we go in, we go see our doc, and we're able to give a fecal sample and say, hey, based on your fecal sample, you're likely to respond to treatment or you're unlikely to respond to the standard course of treatment. And if you're unlikely to respond to standard course of treatment, maybe we should do something a little bit differently than 50 days in the hospital and expect the same results when we know that your bacterial signature suggests that you're unlikely to respond. I don't think it's clinically actionable yet, but this is, I guess, the beginnings of it. Now, this is where I feel a little bit better about this slide than when I first kind of identified this one particular bacterial taxa called Coprococcus. Remember I told you those two other studies that were in the literature here in the Netherlands and here in China? Well, all three of us, we found that this particular bacterial taxa, Coprococcus, was actually reduced in the context of depression. This is, you know, our 100 or so psychiatric inpatients. This is our 100 or so folks with depression getting seeing their primary care doc and identified with depression. And this population in China was more of your acute psychiatric population, not this longer term psychiatric population with depression as well. So all three of us, you know, the geography here is very different from here. The topography is very different. The air we breathe, the foods we consume, the diet, the upbringing, all of this. And I mean, this was buried in a footnote in both of these studies out of the Dutch sample and the Chinese sample. So I didn't make too much of it at the time, but did want to highlight that Coprococcus was reduced in all three of our samples. And curiously, it's Coprococcus, a reduction is actually associated with chronic inflammation, which goes along with our understanding of psychiatric illness today, that it is, you know, associated with inflammation, especially depression. So this is early days. And so, you know, next set of analyses, again, a very, very busy slide. And this is, but I will let you kind of, this is very complex machine learning that super bright computer scientists, engineers have partnered with and are able to do. This is beyond kind of my full understanding, but I will give you kind of to summarize this. Let's go through an exercise of ocular analysis, meaning we're going to eyeball the data. All right. So these are folks with depression resistance or depression response at the end of the hospitalization. If you look at this lower hand corner right here, that this box, this triangle looks different from this triangle, right? This is anxiety treatment response or resistance, again, to our ocular analysis. This triangle looks different than this triangle. Now, what we did was I looked at depression and anxiety again as both together, and in this particular look was because, depression and anxiety being so horribly comorbid, and some might even argue that, they're really the same disease state, just different expressions thereof on different sides of the coin, if you will. So we were able to identify from, 10,000 plus, probably bacterial taxa, um, 43 of 44 overlapping taxa that differentiated depression and anxiety treatment resistance. And of these, they were associated with inflammation. Again, the story is really depending on how we slice the data, looking at it. In this particular data set, it's depression and anxiety treatment resistance. We could identify early on based on what your bacterial signature could look like. That first study that I showed you right here, this was just bacterial richness, just kind of the diversity, generically speaking, that was the metric. This particular study, we took the microscope further down and identified 43 of 44 bacterial taxa that were associated with both depression and anxiety treatment resistance. So like the microscope is getting finer and finer from just, hey, these people have less biodiversity, and it may be Coprococcus, but now it's turning into a little bit more of a complex picture, a richer picture of, we've got it down to, a few dozen bacteria that may be identifying you as having a different disease that may not respond to more traditional treatment. So what we have found out subsequent to that, now this one is, this is out, I think towards December of last year. This is a group, again, out of China that published looking at how the gut microbiome and metabolic pathways might be implicated with SRI treatment for depressive disorders, and really found that, again, a select number of bacteria, in this case, Rhamnococcus, Bacterifidum, and Facilibedium, were more abundant in folks who responded to an antidepressant treatment. So kind of what your gut looks like, you can take medicine and some of us are going to better respond to that medication based on what our gut looks like. Again, this is a small study, so let's not get, jumping up and down, but you can see how this signal is starting to gain a little bit more traction, and a little bit more specificity of maybe we can look at what the gut looks like early in the course of initiating treatment, and we might be able to better predict who may or may not respond to our course of treatment. Again, this one came out just very recently as well. This is a 2024 publication, and they were able to identify this particular metabolite, so not just the bacteria, right? So again, you may have this bacteria, I may have this bacteria, but there's so many of them, right? One would expect that there's probably some redundancy built into the system, that we can have this bacteria or that bacteria, and really it's less so about the bacteria, but what they produce, their metabolites, right? So this study, I think, is a fantastic addition to the literature. It's not talking just about the bacteria, but it is identifying this particular metabolite that is associated with whether you're responding to treatment or not. So again, the signal is getting sharper and clearer, but this is from like last quarter, so somewhere October or so of 2024. So we're very early, very, very early in our understanding and nowhere near clinically actionable. So our group also looked at, if depression is associated with the gut microbiome, and anxiety, and so we looked at, to say, all right, well, depression, anxiety, they tend to go part and parcel with suicidality. maybe this is also what's going on with suicidality. And really, we were able to say, not so much. It's not suicidality. This is I put up the slide not to say that we'd found nothing, but to really kind of flex a little bit here and say published non-significant findings. How about that? So somebody somewhere, this study was meaningful enough, and it's really expensive. I wish we had more non-significant finding publications out there. That I mean, I chopped and sliced and diced these data every which way possible, put in all this money and effort and expertise, and we found absolutely nothing. That's not to say that the gut microbiome may not be at some day implicated in our understanding of suicidal thought and behavior. But based on kind of what this particular study did, don't repeat these mistakes. Do something different. So big meta message. This is a good study to know what not to do if you're looking at the gut microbiome and suicidality. This was another kind of unique finding in that data set as well. So the average age of the population is, about 37 years old. So, well into adulthood. And this population, we also not only asked them about their symptomatology, but we asked them about kind of life experiences, including traumatic life events. And curiously, the folks who had experienced childhood physical abuse, they look different from folks, their bacteria look different from folks who did not experience childhood physical abuse. And those bacteria were the folks with childhood physical abuse had a greater abundance of pro-inflammatory bacteria. I mean, think about that. You're 5, 6, 7, 8 years old. You get beaten. You get bullied. You experience physical abuse. 3 decades later, your gut still remembers. It's different, right? So whatever happened during that time, I mean, it probably resulted in early childhood, results in some epigenetic changes that continue on decades later. I think that's fascinating. And it's just really, I think, really worth, I mean, this signal is starting to really come together. This is one that just came out. I'm really proud of this paper. This is in press. This will come out probably later this year, 2025. And this is, again, long time in the making. What we looked at was we're looking at personality features and traits among our population and seeing how that might how the gut might look differentially based on personality traits. Had a couple of hypotheses going into this, thinking that folks with more cluster B pathology, the sex, drugs, rock and roll lifestyle, just because of their health behaviors, would look different from folks without more cluster B pathology. And then also was hypothesized that folks with more extroversion, more social engagement, they would look different from folks who tend to be more reclusive and socially disengaged, based on the hypothesis that there's an emerging literature, the kind of the social transmission of the gut microbiome. From the earliest data, as I was mentioning earlier, we're all born germ-free. We pass through the birth canal. That literally is our first exposure to bacteria. We touch skin early on, and then that's how we get bacteria. And there's growing literature to say that there is a social transmission of our bacteria, which I think has huge implications downstream. But to this specific study, we actually did find that the bacteria, the folks who endorsed an item saying that they lack close friends or first-degree relatives, or looking at the PID5 and looking at the detachment domains, it's that their bacteria did look different from folks who are more socially engaged. And lo and behold, be the broken record, the bacteria that were more prominent in folks with social disengagement tend to be more inflammatory, related with inflammation. The sex, drugs, and rock and roll cluster B hypothesis didn't hold, but this one was kind of interesting in that our social engagement the networks that we keep, the people that we're around, we're actually sharing bacteria with, and it's the more bacteria, we tend to be, or the more disengaged we are, we tend to have more inflammatory bacteria. Now think about this in terms of the loneliness epidemic that's affecting all of us. It's killing us, actually. Might the gut microbiome be implicated? There's plenty of literature to say that, married couples who have been together for decades upon decades, 40, 50 years, when one dies, the other dies, often within 6 months of the initial spouse. What if this is gut bacteria related? You lost part of that balance of the bacteria with your partner. Now, all these are wild out hypotheses, but I mean, you can see how the social transmission might have to do with something. Now, take this a little bit step further. There's no empirical basis to this at all, and I will say this out loud as a hypothesis that I hope to test someday. Might this influence our therapeutic relationship? Might the shared bacteria you and I have with our patients be kind of part of that therapeutic relationship that is foundational to all our treatment outcomes, whether that's psychotherapy efficacy or medication efficacy? If the therapeutic relationship has huge bearing to those outcomes, and might our shared bacteria with our patients have some bearing on that? And if so, how does our telehealth platform, how does that affect and is affecting our treatment efficacy? Again, no data to this. This is just taking one small study and extrapolating way beyond it. But curious to think about and fun to kind of chew on. So kind of what we know today, I'm going to kind of put the speed up a little bit here. And so this is kind of the big literature. This came out a couple of years ago in Molecular Psychiatry. I'm going to focus on this Venn diagram, these shared bacteria, this Egersella, Lactobacillus, and there we go, Coprococcus. So I feel a little bit better about this. This is looking at kind of a systematic review of everything that was out to date of 22, and we found essentially these bacteria. And let's go a little bit different. So across psychiatric illness, whether we're looking at depressed populations, psychotic populations, bipolar populations, this bacteria, Egersella, tends to be elevated. This particular bacterial taxa relies on lactic acid, and this affects neuronal metabolism, and it contributes to inflammation. All right. Now, this lactobacillus, this is all over the literature. This tends to be a little elevated, same as Egersella, but also it can contribute to inflammation. But this has got this weird thing, right? So it tends to be, if you don't have enough of it, you probably need to have some supplementation. But it tends to be generally neuroprotective. But what we're seeing is when you have too much of this lactobacillus, it's probably reflective more of an imbalance of your bacteria, where you have a relative overabundance of not just lactobacillus, but other bacteria that aren't so good for you, at a relative expense of an underabundance of bacteria that might be better for you. Coprococcus, as we were talking about, this tends to be reduced in psychiatric illness states. And what this is involved with is this bacteria actually ferments dietary fibers that produce short-chain fatty acids like butyrate. All right. Now, our short-chain fatty acids are all neuroprotective. They reduce inflammation and promote neurogenesis. But if you don't have these bacteria, right, this Coprococcus in particular, or you don't have dietary fiber, one of the two, right? you're going to have a reduction in production of short chain fatty acids. And if you have that, you don't have those short chain fatty acids, butyrate in particular, you're going to have more inflammation and you're going to have less kind of neuronal cell growth and development. So this is kind of an emerging signal. I think this is where the state of the science is these are likely to be or suspects moving forward, but this is by no means the entire picture, and this is an evolving understanding of what's going on. So kind of next steps right now that I've got a couple of projects going on with is we're discussing. I mean, we've done well with what we've done, and I think contributed to the literature, but it's also cross-sectional. So it's really my question next is does this gut bacteria, is this our destiny, or can it change and evolve? I think that there's emerging literature to say that it can change and evolve, but really it's as you're in treatment, does the bacteria, does the balance, does what the gut microbiome look like, does that change? Does that respond to treatment? Does that change first before you have symptomatic improvement, or do you need symptomatic improvement before and then you subsequently see change in the bacteria? We don't know. So I've got a study underway that's looking at folks who start treatment and then collecting fecal samples with them at admission into outpatient care, 1 month, 2 months, and 3 months, and seeing how their gut bacteria and their symptoms might change. There really isn't anything in the literature so far. There's one paper that says, your gut bacteria may kind of get more diverse with SRI treatment. They may return to more balance with SRI treatment. But again, the studies are very small. They're very few in number. So it's, and I'm doing the same thing, looking at the gut microbiome in the context of treatment for opioid dependence. This is just fantastic, right? So, I mean, opioid epidemic is affecting all of us. It's not fantastic and people are suffering. It's fantastic in the science, I think. It's just, so there's not been much done in the space of opioid dependence, even though we know, I mean, it's just low-hanging fruit in so many regards, right? So opiates, I mean, they directly affect our gut functioning. I mean, they slow motility, right? I mean, they really slow down motility. And then one of the biggest challenges with opioid treatment is, people being dope sick. It's that horrible, debilitating diarrhea that comes with abstaining from opiates, and that's oftentimes that contributes to relapse. It feels horrible. So that data collection is going to start later on this year, and then again, I hope I was able to highlight, it's not just the bacteria, but it's what the bacteria produce. They're metabolites. So this whole field of metabolomics. I got to bring yet another expert into the field, onto the team. And these people are hard to find. And then I'm going to get really, really complicated and say, this is one part of the variants explained, probably through the gut microbiome. And it's, all of us in this quest for some biological markers of psychiatric illness. I don't want to be that kind of tunnel vision saying that everything's going to be with the gut microbiome. I do think that there is definitely a biological contribution to psychiatric illness, and the gut microbiome is likely to be one part of the picture, but genetics are involved. The brain structure and function are going to be involved. So how do we look at kind of multimodal data and including other markers of inflammation? So that's aspirational that I'm hoping to start hopefully this summer. And all of us, looking for the grand search for these psychobiotics that are going to cure psychiatric illness, right? Whether we're going to feed our good bacteria or starve our bad bacteria, or supplement and replace our bacterial kind of diversity with bacteria that are missing. I don't know, maybe one day we come to a place of psychobiotics. We are nowhere near that. I think that this is a step where we're moving in the direction, but it's all of this is not without consequence, right? So this is very complex, and I think some of the ethics may even have to be taken into consideration of how we advance the science. We can talk about that a little bit more towards the end. All right. So to summarize what we know about the gut microbiome and psychiatric illness, it's based on small animal studies. There's a growing literature with humans and including actual patients with illness, but we are limited to where on the globe we're collecting data, and we have limited understanding of kind of the mechanism of action. So we're gaining a better appreciation. And when it's all said and done, regardless of what CNS disorder we're looking at, what we're really looking at is that there tends to be an imbalance of our bacteria makeup in our gut. And what we're seeing is that we tend to have kind of an overabundance of pro-inflammatory bacteria and or a relative underabundance of anti-inflammatory bacteria, and that's contributing to disease. And again, I would be hard pressed to say that we've got a causal relationship based on the data right now. I think what we can safely say that there is a modulatory relationship between the gut microbiome and psychiatric disease, whereby it's what the gut looks like can either turn the volume up or down on clinical presentation. So Ted Dinan out of York, out of Cork, Ireland, rather, is kind of the godfather of the brain-gut interface. And you know, this is not too long ago. It's just we don't even know what normal looks like. And generally speaking, more diverse is better. So, all right. So what we're gonna do? Let's talk about manipulating the gut. This is all. Nothing is FDA approved. So here's my big caveat. And this was out a couple of years ago. Probiotics can have an antidepressant effect, right? Can, and mild to moderate. I don't know that this is going to go replace our treatments to date, but you know, as an adjunctive, one might consider probiotics to put into the mix. And again, what those probiotics are, it's a mixed bag. And this is the meta-analysis that was done based on the literature to date. Here are the studies. Yes, that's 11 of them. If you go a little bit down here, this is 10 patients were given probiotics in addition to Celexa, 20 patients were given probiotics in addition to Celexa, and 20 were given placebo. This is almost all the studies, all right? So even this meta-analysis that looked at the state of the science in 2013 is based on 11 studies that are based on studies with 20 and 30 people. So really be cautious in interpreting these findings. So yeah, there's a small, tiny little signature that is a signal that is emerging, but I don't know that we're prime time clinically actionable yet. Now, here we go. So this was looking at schizophrenia. And again, this is a meta-analysis that just came out in 2025. This actually comes out in February. So this is ahead of actually in print. This is a meta-analysis of the state of the science, brain behavior and immunity. It's got an impact factor of about 15. So this is a primo journal. These are 9 studies, 7 of them on RCTs. And this is looking at probiotics as adjunctive to standard of care in schizophrenia. And we've got an effect size of about 0.5. But I mean, you can see the spread right here. And there's plenty of nothing. And this one's, a couple of studies are driving it all up. So I don't know if it's a small emerging signal, but let's be cautious in saying that, for all the challenges of our antipsychotic medications, I don't think probiotics are replacing them anytime soon. So, how do we manipulate the gut today? And this is always a question, and this is what I'll bring up today is, promoting resilience. Starting young and doing what's right by kind of overall health. Eat well, exercise, engage with others, keep your mind sharp. This is literally how to promote kind of development of a healthy gut microbiome and maintain it into adulthood. Now, what happens when we don't do some of these things? Like I was saying, an emerging literature there of psychiatric illness and kind of our diet and nutrition being implicated as such. So poor diet. In this particular study, this is looking at kind of ultra processed foods and a systematic review of kind of how this affects us with psychiatric illness. Again, smaller studies, but this is kind of quite a pretty nice signal in terms of depression. 40 some odd percent greater likelihood of experiencing depression if you have a diet high in ultra processed food, and the signal is pretty much the same with anxiety. 47% increased odds of experiencing an anxiety disorder. And ultra processed foods, these are your Fruit Loops, your hot dogs, anything that's made in a factory that doesn't look like it, was born that way or fell from a tree that way. That falls into the ultra processed category. So this is we eat a lot of this. We eat a lot of this. So what are we eating in the United States? So this is CDC kind of data that are coming out. This is about half of us aren't really following dietary guidelines, and it tends to be worse, kind of in a young adulthood and into adulthood. But as we're kids and we get older, we tend to do a little better, but there's still plenty of room for improvement. And really, what's driving it? It's we're not eating veggies, and we're not getting enough protein. We're getting our grains in, but our whole grains we're not. We're getting horribly too many of our refined grains, and protein again. It's we're not doing a great job with it. So our diet is ultra processed foods. We're not eating enough fruits and veggies, and this is across the country. So what happens when we eat kind of some of these bad foods in terms of our actual gut microbiome? That bucket of fried chicken, with the milkshake and the donuts, we get the cytokine flare up. We've got some bacteria that might be associated, but really what we're seeing is inflammation. We pile on horribly again with red meat, and I say this coming out of Texas, where all the cattle, all the beef are actually produced. And I love steak, so this and burgers. This is really painful for me to speak about, but it's not exactly great for you, and it has CNS effects. Now, diets high in fiber, mind you, we're not eating enough fiber, are really good for you. So lead to, remember again, the Coprococcus, they ferment these fiber, leading to short chain fatty acid production, especially butyrate, acetate, propionate, leading to anti-inflammatory effects. So I always get asked kind of what some specific guidelines and guidance. It's, many of us look at food labels. We're looking at how much fat we're consuming. We're looking at how much sodium we're consuming. We're looking at how much protein we're consuming. One thing we may consider is looking at how much fiber we're consuming, depending on age, gender, anywhere about 30 grams a day is what is recommended. The vast majority of us are not getting. The vast majority of us are not getting enough fiber. And so eat more fruits and veggies, add an apple. What happens when we change up our diet? A whole lot happens. This is the state of the science. This is out in 2017. This has been published many times over. Change your diet. I mean, look at this listing right here. This is, and this is, eating a very healthy, balanced diet, and reduce, not get rid of, reduce, right? Let's reduce all of these things that we know aren't good for us, and lay off the alcohol. Again, it's not stopping. And we had an effect size of greater than 1 with this study, right? Looking at depression outcomes. Most antidepressants, effect size of about 0.3, 0.4. All right. Most psychotherapy, about the same, 0.3, 0.4. This is an effect size of greater than 1. If a pharmaceutical company could come up with an intervention that had that big of an effect size, they would be making billions. But this is easy in terms of concept and very hard and complex to put into practice. So here's my big take home. Eat more of this, less of this, and maybe some of these, more fermented things like kimchi, kombucha, kefir, apple cider vinegar, that might improve. So generally speaking, we can manipulate the gut. I don't think we're there with the probiotics. I do think we are there with dietary intervention, and probably kind of the lowest, simplest thing that we could do, given that greater than 90% of us aren't consuming enough fiber, is eat an apple a day. All right, so this has been done over many, many years, many shoulders that I've had the privilege of standing on throughout the decades. Colleagues in Chapel Hill at Medical University of South Carolina, colleagues over at the Menninger Clinic, and continue to partner with folks at Baylor College of Medicine, and really appreciate the team at Houston Methodist, especially close friend and colleague, Dr. Weinstein, and really all the folks who have given me their fecal matter over the years, and sharing their personal information and data. With that, we'll stop and leave it open to questions that y'all might have, comments, concerns.
Hello, we need another hour of questions for people interested out there. That was tremendous oversight, and you are such an inspiration, really, to kind of take on a new field and label it, and keep asking questions with curiosity, and share what is known and not known, and interesting questions. It's just really a joy to share a screen with you. So thank you for.
Appreciate it, Jeff. Appreciate it. Thank you very much.
So we have 29 questions and 15 more to go. I'm sure it'll be up to 45 before we blink. I'll take them generally in order, but there is one question I want to start with because I'm so interested in this isolation and loneliness question, and we have a couple of questions in the chat that refer to this. Do you think that this is exclusively kind of a contagion effect of kind of passing bacteria when we have more social context, or is there something about the isolation itself that does something to our gut bacteria? I guess I'm wondering if somebody has more Zoom contacts, for example, and is not experiencing feeling lonely, is that the same as isolation, or is this really a question of passing bacteria back and forth, like the examples in the vaginal delivery and how we get our bacteria in the first place?
Yeah, that's fascinating, Jeff. This whole loneliness thing is really kind of piqued my interest as well. I'm going to argue that it's probably both. Speak outside both sides of my mouth right here, because even our study, right? I mean, we were able to, explain plenty of variants, but it was only about 20%. Right, of the social transmission of the bacteria. So I do think that there is something to be said for a shared physical space and the bacteria that we pass back and forth, including the shared touching that we do, the doorknobs, this, that, and the other. I do think that that has some bearing on what our bacteria look like, but I don't think that's going to explain all of the loneliness phenomena. So, I mean, might that be modulated with folks who tend to be more socially engaged via Zoom, telephone, letter, whatever, that they're able to kind of keep other parts of their psyche kind of higher functioning and maybe kind of compensate for the lack of the shared bacteria. I don't know. I mean, it's probably both. That would be my understanding. Again, anything kind of gut bacteria related, I don't think this is the entirety of the picture. This is one piece of the puzzle that probably accounts for, you know, some part of that variance and whatever outcome we're looking at. And it's just something that we, as the state of the science, we just haven't considered. So all of this, I think we've attributed this to almost like error or unknown or noise. And I think some of that error or noise is probably gut bacteria related.
And I apologize to those whose questions I'm not going to be able to get to in advance. But some I think are general. I want to pull out the question before we have to stop about places of further information, Alok, about this. Are there national conferences? Are there journals? Where can people actually stay kind of abreast of information as it develops in this area?
This is, I mean, type in gut microbiome and your disease state into PubMed or Google Scholar. You're gonna get this is this is coming out at breakneck speed now. The science is moving so very fast at this point. While we were early in this field a decade ago, we've long been surpassed by shops that are producing just so much information so quickly. A good resource for kind of more dietary guidance. I really like, and this is for some that might want further training in terms of kind of more dietary training, nutrition training. It's called the Food and Mood Center out of Geelong University outside of Melbourne. The director, Felice Jacka, she is just she's the one that I just presented on that greater than 1 point antidepressant effect. She's really been taking the charge in this nutritional psychiatry realm, and consults with the World Health Organization. I had the privilege of having dinner with her a couple of years back when she was in Houston. She was consulting with NASA. As we're going to the moon and beyond Mars, it's what are these meals that we're going to be consuming and how is that going to affect our health and well-being? So she's actually kind of writing the menu, if you will, for space exploration. And she's got fantastic science. Just her shop is doing great work in terms of dietary and nutrition science and how the gut microbiome is implicated. I think that's a great resource out there with good science.
The Food and Mood Center. Great. Thank you.
Mm-hmm.
So, there's a question here that's interesting about kind of GI side effects of SSRIs. And do you think that that has anything to do with their efficacy, or would you? The person here says that they have a patient and they were taking Miralax, and then the SSRIs seemed to stop working. Do you think that there is anything about efficacy of antidepressants and kind of the function of the GI system that's known?
Ooh, probably. Now here I'm going to go out on a limb and say SSRIs are kind of one of our first psychobiotics. We have more serotonin receptors in our gut than our brain. So might we be actually manipulating the gut to have our even our SRI effects? So yeah, I definitely think the SSRIs are implicated with the gut microbiome. How? I don't know exactly, but I know that we've got a bunch of serotonin receptors. And then, there's, again, we can look at the pharmacogenomics too, and there's going to be kind of genetic risks for those side effects as well. Again, the picture is, it's complicated, but yes, I absolutely think that there is some implication there.
Great. Can you say, there's a question here about wanting to know if there are any studies enrolling participants following up on years after fecal matter transplants due to C. diff. Any comments about that, or generally about fecal matter transplant. And
So yeah, there's a lot of hope and hype with fecal matter transplant. All right. So it's the FDA just approved it. I want to say 24 or 23. I mean, this is not a long-standing kind of intervention out there. It's still in the early phases. So I don't know that we have enough long-term study, long-term being probably not greater than a year out. Curiously, during the process of these studies, we have learned a lot about fecal matter. And so some of these early studies, we got healthy fecal matter. We were able to cure disease in terms of C. diff, but we also transplanted obesity. So this is where it's really it's the whole, and there's small tiny case studies out in the literature saying that fecal matter transplant cured my bipolar, cured autism, and these are again ends of one out there. I don't think the science is there, and as I alluded to, I think we really need to take kind of ethics into consideration, that we may be trying to treat something, but we may be kind of inadvertently having iatrogenic consequences in terms of transplanting disease too from supposedly healthy fecal matter, right? So we could be transplanting time bombs in some ways. So we have to be very careful, and I don't know that we're there. With the C. diff, I think that the ethics of it were like these folks they had not responded. They're going multiple times to the hospital. They like kind of the life and death type situation, right? In terms of their health and well-being. So I think once it gets to that far, the risks outweigh the potential, or the benefits outweigh the potential risks. And we're safe to about a year out. We'll see what the long-term data say with C. diff, but we don't have that right now. And I really caution against moving too quickly with other diseases, especially psychiatric illness.
Wow. Is there questions here about available tests for the general public that look at our gut microbiome and can our baseline and what improvements should be made, of any, in your opinion, about when or should psychiatrists in general be using that to augment diagnosis?
All right. So this is going to be kind of harsh opinion, if you will. All right. And this is where I really throw up not just the caution flag, but the red flag. There's nothing clinically actionable right now. All right. Let's really just accept that as our reality in terms of what the gut bacteria specifically look like. All right. Now, there are a number of companies out there that are saying otherwise. All right. Now, these companies are there. They are selling their proprietary diagnostic tools with their proprietary analytics and then their proprietary supplement to modify. So they own the test, they own the algorithm, they have the black box, they tell you the results of that black box, and the only treatment for their finding are available through them. That just reeks of fishiness, right? And manipulation and taking advantage of a society that is desperate for help, all right? Now, what I can tell you is let's get very, very basic, all right? Get our patients, let's start talking about our gut function. Get our patients to actually track bowel movements. Look at what your stool looks like, right? And it can be, is it formed? Is it loose? Are you constipated? Are you having a bowel movement every day? Are you having 8 bowel movements a day? And really, that would be a starting point. But I don't think there is a diagnostic test out there. You can get plain and simple, and you don't have to be a psychiatrist to do this. We can all ask about poop, right? That is a health behavior that falls under any one of our letters after our name. We can do this. We're afraid to, and we don't do this. We're scared of our poop. We're scared of bowel movements. We're scared about talking about diet. 8 diet sodas a day aren't good for you, right? And we don't have to get all, go to the far end of only eating from whole foods all day, every day, right? It's let's try to eat more real food that, the way that it was kind of born or the way that it came from the ground, less processed foods. And again, I'll go to the biggest intervention that we can do just normatively, knowing that 90 some odd percent of us aren't eating enough fiber, is literally prescribing an apple. And I choose an apple in particular because there are probably like 50 varieties of apple out there. You can find one apple that works for you. The apple, you don't need any utensils. You don't need to keep it refrigerated. You can carry it with you. It's just like all the excuses and barriers to actually doing it. So you don't even have to ask about gut health. I just supplement everyone, say everyone eat more apples.
So this is correct. An apple a day. Keep
I think so. I really do. Keep it simple. I mean, this is it really, that's a starting point. 97% of men don't have enough fiber in our diet. 97%.
I'm gonna go eat an apple in 4 minutes, although
Exactly. I mean, let's start with that. We just, and that we know has direct bearing on feeding our good bacteria. It's that fiber.
great. Many questions here about the relationship of, or what we know about early traumatic experiences or childhood abuse and um, gut biodiversity, or do we know anything about that?
I mean, ours was one tiny little study that contributed to the literature. As we're learning, kind of across the board with just adverse childhood events, traumatic life events, they're bad for us. They have genetic and epigenetic consequences. They have effect on neuronal structures and function. Autonomic tone is affected, and not surprisingly, we're also seeing that the gut microbiome is affected. So this is part and parcel of the big picture. It's like, let's keep ourselves. We as humans are bad to one another. And some of us really get the bad end of the stick, and we accumulate more traumas than others. And the more you have, it has systemic effects, including the gut microbiome. So it's like, again, let's try to be a little kinder, gentler to one another, and hopefully has societal consequences at the gut microbiome level.
Grouping a few questions together here. Do you recommend then probiotics to your patients, or what resources do you give patients to improve their gut biodiversity?
Be informed consumers. That's the best I can tell folks, right? It's there are probiotics out there in a variety of forms. I think if you're going to manipulate your gut, if you're concerned about your gut bacteria and you're looking to manipulate it, it's easy to go to a probiotic and much harder to really look at your diet. If you're going down the road of gut microbiome manipulation via probiotic, I'd say start again with looking at your diet. It's less out of boxes, less out of plastic bags, and more from, kind of the recommendation I have is walk around the perimeter of a grocery store, stay away from the aisles. It's all if you can do 80% of your shopping from the perimeter of the grocery store, as opposed from the aisles, you're going to have improvement in your overall health.
I'm going to do that chewing on my apple, Dr. Last question here. You showed us the relationship of the brain and the gut, and there were two arrows, and one kind of, and so there are some questions here around maybe the relationship of the brain and its and psychiatric illness or experiences and an impact on the gut itself, perhaps in the kind of elaboration of inflammatory bowel disease, those kinds of things. What do we know about that in a
Yeah,
minute?
yeah, in a minute. I guess I do. I have a relative bias, just presuming that folks have a better understanding of kind of the down direction. Our CNS has direct implication on gut functioning, right? I mean, we've got an entire enteric nervous system that is in our gut. It's think about our stress response, right? We have to any life stressor, we have a bump in autonomic tone. Bump in autonomic tone results in direct GI implication in terms of just we slow down motility, right? We have all these neurotransmitters that go, they're floating all over, and we've got serotonin receptors all through our gut. And then here's this big one, the vagus, right? I mean, that's a big signal down to the gut. So it is very much bidirectional. I guess my talk has emphasized, maybe thank you for pointing this out. I can do a better job of kind of emphasizing the bidirectionality of it. I just presume that, that the top down is a much better established in the literature than kind of the bottom up approach influence. So I like that. I think I need to balance that a little bit more, talking about kind of direct implication of CNS functioning on GI.
Well, I love your actual ongoing kind of self-reflection. It's a model for all of us, but that's talk, my friend. So thank you. Um,
Absolutely, sir.
Jen,
Appreciate y'all.
we could go another hour, the questions, and my apologize for anybody these questions I couldn't get to. The slides will be made available to folks when you fill out the survey for continuing education credits. And once again, thank you, Dr. Madan. It's been uh, a joy to connect with you and be with you here in this space. And I think that the true is true with all 450 of us who signed on today. So thank.
Appreciate you, Jeff.
We'll now be left alone in our offices. And so to remedy that, let me just send thank you and gratitude to Houston, Texas.
Appreciate y'all. Take care. Bye.